This is the Hing Hon EK-001. It's a Chinese-made keyboard that was designed in mass as a kid's toy. It comes in all shapes and sizes, it comes in a few completely different internal designs, but the output is always the same: rich, analog square wave tones. It was one of the first things that I tinkered with while getting into circuit bending, and it's still my all-time favorite. So much so that I grabbed hinghon.com at some point. They've gotten to be kind of hard to come by these days, so it's been a while since I've picked one up to modify. This version, which takes advantage of a breakout box for the primary controls, is number 26. So here is the keyboard itself, and here is the breakout box, which I'll get to in a minute. So down here we have this red switch. This is our main on and off. Over here is our power LED. Now this does have a stock sliding switch for on and off, as well as two sliders for volume, but I have opted to just solder these in place at max volume and solder this in place as on, just because these sliding switches can get a little scratchy over time. And we have another way to control the output volume. So a proper switch for on and off is just preferable. So this thing is still able to function totally independently. It's got its internal speaker still in there, though we do have a switch here if we want to cut the internal speaker if we are using one of the added outputs. There is a stock 1/8 inch output here. We have a touch contact for vibrato. Touching this while using the keyboard will lower it by a few notes. And this is a switch for the internal pitch circuit. We have an input. This is stock. We have a gate/trigger input for the kick, snare, hi-hat, and cowbell. And this is our 15-pin connector to connect up to the breakout box. So let's get that hooked up. So this box hooks up via this 1-to-1 15-pin connector. It's got a 1/4 inch output on the back and a volume knob on the front. So this pitch circuit that I mentioned earlier, if we bypass this, this will allow us to then control pitch very heavily with this knob. And then kind of the star of the show here are these three knobs down here. These are different types of feedback, distortions, modulations, glitchiness. Starting on the left right here. These also function independently. This middle one here will latch the last two notes that you've hit, and then start overdriving them the more that you push it. And this last one is kind of like a squeaky, pulsating sound, kind of like that. And this will also start it starts kind of breaking up the sound if there's something going into it. Now all of these work really well together in different ways, especially with these drum sounds. So let's keep this rhythm going. Let's cut all of them on. It's kind of like a total gabber machine. Anywho, I could definitely just keep playing with that. Over here, I did not mention earlier, these are 4 Gleix switches. So each of these correspond to one of the different drum sounds. my favorite is probably that snare one. Now, with these engaged, we can also get those glitches triggering by dialing up some of this distortion, which sounds pretty gnarly. So it is worth pointing out just how much a lot of these things work well together, but a little less so independently, and that's just one of those. These work really well with distortions, not quite as interesting with some of the other modifications. So I'm sure you've noticed these switches above each of these knobs, these just turn them on. So these are completely off, they're not going to function while these switches are in the down position. So right here we also have an optic theremin, a little light dependent resistor for the for that distortion. So if we were to cut this switch on, and we can control that distortion with how much light is hitting this sensor. And then we've also got the same type of thing over here with this sensor, but this is for pitch. There's a lot of light. This up here is our LFO. In the up position, it affects pitch, and the LED is green. This is our rate, shape, and depth of the LFO. Depth being how much it's affecting whatever circuit it's being sent to. And this shape goes between triangle and square in the rightmost position. So you can get fairly detailed, you can go really nuts with it, or you can just use it to make a vibrato. And then in the down position, the LED is red, and this is now going to the distortion circuit, which also ends up acting a bit like an amplitude, so sort of like a tremolo. Over here, these three switches are some independent functions that I thought were kind of interesting. This one on the very left is just a tone generator. This switch in the middle will adjust the way that a rhythm is playing and inject some bass and give it kind of a low pass. then this on the very right is a latch for the keyboard. And it will latch the last 2 notes that you have pressed. This is only a duophonic keyboard. And then up here we have kind of an experimental patch bay. This is a way to start sending CV to this machine, as well as experimenting with cross-patching and stuff like that. We have our LFO output over here on the very right. This is our pitch, this next one over, and then the rest of these are different points to the distortions and stuff like that in here. So let's start a sequence here on the Moog. Let's take the gate. Let's send that to the hi-hat. So now we're getting a hi-hat on every step. Let's send this. This is sending a random voltage on each step, so we can occasionally trigger the snare. And it does not have to be a gate trigger signal. It can be something like an LFO. So if we have our square, it's going to pulse when it's on. Back to our kick. Let's take our triangle LFO and send it over here. Now this top 1/8 inch jack here on the keyboard is actually an audio input jack. So this will let us take audio from an external source, feed it into here, and then process it so we can get that same kind of crazy modulation on an external source that we do on the keyboard. So let's just get a drum loop going. Let's see what we could do with the guitar. We can get kind of a tremolo distortion. And then lastly, I feel like I should also go over the stock voices here. I've been using organ throughout most of this. also got violin, piano, horn, flute, guitar, music box, banjo. So you can tell they're all kind of variations on like two different sounds, one being that organ and the other being just a straight square wave, just with different envelopes on them. Some of these modifications work with certain voices better than others. If I turn on the latch, I think this is piano right now. There's organ. Then something like the violin doesn't latch quite as loud. The sustain is a bit quieter than the actual trigger. Here's horn, flute, guitar, music box, banjo. Some of these do pretty well with the distortion. The violin specifically, you can get a nice wow 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 type sound. So that ought to give you some idea of what this thing is capable of and how it sounds. It's just raw, aggressive, heavy, distorted square wave madness. It's really difficult to go in depth into everything, and this video is already way longer than I intended it to be. This has been more of a demo of what these modifications are and how they function, but there are so many things in here that come about as a result of different mods working in tandem or with particularly set parameters that I just can't get into. There's a section of my website, gleix.net, dedicated to all my previous EK-001 builds, as well as a video playlist on my YouTube page, so if you're looking to hear some additional demos, this build is similar to a few of them, including the one that I built for the Moog circuit bending competition in 2014, which also has a fairly in-depth video. And lastly, this device is for sale. If you're interested, my website again is gleix.net, and you can find this at the store over there. You can also find a catalog of previous builds, and if you see anything you like, feel free to reach out. I am typically open for commissions. So thanks for checking this out. Stay safe, stay healthy, wear a mask, check your voter registration, and I will see you at the next one.